So 2022 May. The probability of two events A and B are illustrated in the Venn diagram below. It is given that the probability of A complementary intersection B is 3x and the probability of A intersection B complementary is 4x and the probability of A intersection B is x. Select the missing probabilities to complete the Venn diagram. Now it's pretty easy that we have been told that the probability of A intersection B, which means the common region between A and B, is supposed to be x. Hence I can write this value is going to be equal to x. And automatically, when I have only this value left of 4x, I will write 4x here. So that will be left with our complete answer. Part B says write down the value of probability of A union B. Alright. So A union B is basically the combined probability of A and B, right? Which perhaps looks like this. This one. Now, you see, what have we been told here? We have been told that there is an external probability, not an external probability, rather a probability that was a part of the universal set but not a part of these sets, and that has been given to us as 0.2. So the probability of A union B, which is present inside both of those sets, is supposed to be simply 1 minus 0.2, and that is equivalent to 0.8. Alright, then we have question 1 part C that says find the value of the probability of A intersection B. So essentially A intersection B is this, and they are telling us find the value of x. Now it's realistically not straightforward to find the value of x, but at the same time I know that when we add all of those probabilities it adds up to 1, right? So I can say that 4x plus 3x plus x plus 0.2 is equal to 1. Then I can say 7x plus x equals 1 minus 0.2. I get 8x equals 1 minus 0.2 becomes 0.8. And hence the value of x becomes 0.8 divided by 8, which gives me an answer of simply 0.1. So the probability of A and B happening both at the same time perhaps is 0.1. Then what have we got? Then it says, hence identify if events A and B are mutually exclusive. So we can see here that A and B are not mutually exclusive. Alright? Because we see that they essentially have a point of intersection. So it is highly possible that those events take place at the same time. Alright? Events A and B happening place at the same time is somewhat possible. It's less likely, but it's not impossible. So, since there is a value present in between, I can say that they are not mutually exclusive as they have an intersection value. So that's how we will get the right answer.
I'm done writing.
All right, let's move forward. Determine the length AF. All right. So the length FC is 5 meters. The length DC is 5 meters. The length AD is 5 meters. So essentially speaking, we have a right angle triangle. The hypotenuse is 10 and the base is 5. So we can write this by 10 square minus 5 square. If we do that, 10 square is essentially 100 and 5 square is 25. So we get 75, but we should get an under root of 75. Now, since it does not say find the exact length of AF, so when it comes to exact length, you should use the idea of surds and radicals. We should convert this into a decimal form ideally. So we are going to get somewhere around 8.7 centimeters. That is going to be our correct answer. Show that triangle AFC is similar to triangle AED. AED. AFC. Let's have a look. Hmm. This is related to similarity and congruency. This is not a congruence question though, but how to solve this part? So you see, if you were to look at the value of the angle EAD, this one, or at the same time, we would have to look at the value of angle FAC. The value of this angle is going to be numerically equal. So it's basically a common angle or same angle A, right? So I can say that first things first, angle of A in EAD and FAC is equal, hence both triangles are similar. At the same time, I can say that looking at this right angle triangle, they both are right angle triangles and they both have a 90-degree angle. So I can say that angle E and F are both equal as both are 90 degrees. So that is going to be the correct answer. The next part says, hence find the length of AE. Okay, AE. All right, not too difficult. I know that the ratio between angle AED and angle AFC is basically 1:2. As we can see, have a look. This triangle and this triangle. All right. So it's essentially half of each other. So I know that the value of AF was 8.7. So the value of AE should be half of it. So if the ratio is 1:2, so the value of angle AE or length AE should be X, and the value of AF is 8.7. So essentially we do it in the ratios method. So you get 2x equals 8.7 and x equals 8.7 over 2, which gives us an answer of 4.35. And here you go, this is our answer of 4.35 meters. That's how we'll get the right answer. We could have done this using trigonometry as well, but it's not needed right now. Let's move forward. Question 3. Some statistics. The following data is based on candy product in a factory. A quality control manager samples 150 bars of candy and records the weight in grams of each candy bar. The data is shown in the cumulative frequency diagram below. Alright. There are 12 candy bars in a pack. Using the median weight of one bar of candy, determine the weight of a pack of candy. So there were a total of 150. How many? 150 bars, right? And a total of 12 candy bars. Determine the weight of one pack of candy. Hmm. Let's try to solve it. Alright, we can look at it this way. So the middle value, so between like basically from one value to the other, the mid value is going to be this one. 75. This is 70, this is I think 75. Yeah. So this represents roughly 15.19 grams. I guess 15.1, yeah, 15.19 grams. And that is the value for 1 bar of candy. So if we want to find the median weight, that's pretty simple. What we just have to do is that we have to multiply 15.18 multiplied by 12, and we get an answer of 182.16 grams. That's going to be the median, the weight of a pack of candy. All right. Now, 3b says determine the value of n. The candy is categorized by weight into three different sizes. So from 15 to 15.1, there is a frequency of 10. From 15.1 to uh, K, it's 120. The weight is in grams. And then there is K to 15.4. So we know that the total number of candies was 150, right? So 10 plus 120 plus n is equal to 150. So making n the subject of the equation, we get 150 minus 120 minus 10. We get a value of 20. So 20 is going to be our correct answer. So that's n. What about the value of k? Hence determine the value of k. Alright. So we have to look at it using the cumulative frequency curve. Now I know that looking at the cumulative frequency, if we add 10 and 120, we get an answer of 130. Alright, an answer of 130. So let's extrapolate the graph at 130 and see what answer can we get closer to. This answer is roughly going to be 15.26. So reading from the cumulative frequency graph at the frequency being equal to 130, if we were to extrapolate the graph down, we get an answer of 15.26. So our answer will be, the value of k is going to be 15.26. Then it says 6% of candies are rejected as the size is too large. Find the minimum weight of the rejected candy. So only 6% are rejected. So let's take 6% of 150, the total value. 6 over 100 multiplied by 150. This becomes 150 times 6 is 900. Divide that by 100 and we get an answer of positive 9. So essentially speaking, only 9 bars are totally rejected. So the non-rejected cutoff can be found as 150 minus 9, that equals to 141. So the 141 candies are um, essentially accepted. So only 9 of them are rejected. But in order to find the weight, we have to use the, the frequency curve. So we go above and let's see where is 141. 141 is present somewhere around here. So that was supposed to be 15.32. All right, 15.32. So the answer is 15.32. The next question says, The functions f of x and g of x are shown in the graph below. This is a quadratic equations question. The values of a, b, and c are different for f of x, g of x, and g of x. Select the correct options to complete the table. Now, have a look at f of x. So f of x is just another way of representing saying y. Okay, so that's the only input that we have in functions in IB MYP, standard maths. So that's the function for y. Now, how do we know what is value of what? Now, let's say I consider all x values as 0. Let's say I write all x values as 0. So, um, if the values of x become 0, the value of y is going to be considered positive. Why? Because we have a positive y-intercept here, focusing on the graph of f of x. So, I can say that the value of c is going to be positive. What about the value of a? Now I know that this is a happy face curve, or a parabola that is a U-shaped parabola. So the value of a is supposed to be positive, right? So I will write this value as positive as well. What about the value of b? So this is a bit difficult to understand because this parabola is opening upwards, and the value of b, so basically the discriminant value is greater than 0. So I'll say that the value of b is supposed to be negative. We've all done this in quadratics. The parabola down is the complete opposite of the parabola up. So realistically speaking, without a concept, I can just say that this is supposed to be negative, this is supposed to be positive, and this is supposed to be negative. But if I want to apply the concept, how would it work? Have a look. If I substitute the value of x as 0, so at that point, the value of y is going to be negative. The value of y is going to be negative. So c automatically becomes a negative value. And for the value of a, what do we have here? So this is an n-shaped parabola, or a sad face shaped parabola. So automatically I know that this value is going to be minus a squared. So hence we get our right answer. That was it for question 4 apparently. Yeah, 4 marks only. The diagram below shows a sailing course for a yacht race. The route for the course is laid out with buoys that the yachts must pass. The details of the sailing course are provided in the table. So basically this is a bearings question, as we can see quite vividly in front of us. So 5 part A says show that the size of the angle HAB is 90 degrees. HAB, where is HAB? Okay, we have to show that this angle is 90 degrees. So that's pretty easy. Here we go. So this angle is 30 degrees. So the opposite value or the length is going to be replicated here as 60 degrees. And this entire diagram, or perhaps this y-axis, is equivalent to 180 degrees, and that is 150 only. So this becomes 30 degrees. So 60 plus 30, when we add them both together, that gives me an answer of simply 90 degrees. So I can say that 60 degrees plus 30 degrees gives me 90 degrees. Then it says calculate the distance from B to H to the nearest meter. B to H. Okay. Then it says calculate this distance, essentially speaking. All right. This is 5 part B. All right. How can we do it? This is the distance that we essentially have to find. All right, let's try to do something about it. Mm, can we use the Pythagoras theorem for it? I don't think so. It's not a right angled triangle as of yet. Okay, yeah, that's not very difficult. We essentially have two angles and uh, two opposite sides, and we can use the cosine rule to find the value. So have a look. Oops. This angle has been given to us as 90 degrees, and the opposite lengths of it is what we have to find, and the two surrounding lengths have been given to us. So using the cosine rule formula, I can say that cosine of 90 equals 100 square plus 250 square minus the value that we have to find of HB over 2 times 100 times 250. So if we were to solve this question, we have to make H be the subject of the equation. So we get cosine of 90 equals 100 square plus 250 square. This has to solve using Desmos. Can you solve it and tell me what answer do we get? Cosine of 90 should be multiplied with uh, 500 times 100 minus 100 square minus 250 square equals to minus HB squared. Multiplied by 500 multiplied by 100 minus 100 square minus 250 square. We get an answer of HB being equal to 269.3, and that is going to be our final answer. The next part says the course for the yacht race is made longer by setting two more buoys at C and D. Okay. They are set as a reflection of buoys A and B respectively on the vertical line passing buoy H. Alright. What are we supposed to find? The race will start from buoy H, and the yachts must pass all the buoys exactly once and return to H. The route for the race will be in order H to B, then A, then C, then D, then H. Alright. That's how it essentially moves. Find the total distance traveled. So essentially speaking, this value we calculated as 269.5, if I'm not wrong. Let's just write it as 269. And this value should also be 269. This value should be 250. This value should be 100. Now, there is some sort of a horizontal set of A, and that is exactly what we have to calculate. So, this distance and this distance needs to be calculated. So, if you want to find the total value, we have to perhaps add all of them together. H to B, let me just pave over the route completely. H to B, then B to A, then A to C, then C to D, and D to H. All right. So this 100 is not going to be considered. Hmm. So we have to find the value of this length x. What angle was given to us above? Let's have a look. This angle was given to us as 60 degrees. Very well done. Okay, let's check. So essentially, if I extrapolate this line further, this angle becomes 60 degrees. So we have to find the complete length, all right? So 100 multiplied by sine of 60, and then we multiply it twice. 100 multiplied by sine of 60 becomes 86.6, and then we have to multiply it by 2, so we get an answer of x equals to 173.2. So in order to find the total distance, we add all of these values together. 173.2 plus 250 plus 269 plus 269 plus 250. So if we were to add all of those values together, what answer would we get? 173 plus 250 plus 250 plus 269 plus 269. That's 1211 meters in total. So that's how we write our final answer. 1211 meters. Let's move forward then. In Africa, masks serve an important role in rituals or ceremonies with varied purposes like ensuring a good harvest. Okay, that's not necessary to read. Most of the time it's just to to waste your time. Okay. So a designer is creating two masks, mask A and mask B. They're created using geometrical shapes and symmetrical properties. Interact with the stage control to see how mask A is created. So stage one, this is the stage control essentially. This is probably for the forehead, this is for the mouth, supposedly. That might be for the other organs. Okay, so that's what essentially we need. That's mask A, by the way. So we have a semicircle, the half of a circumference of 20 centimeters, and the length in between is of 14 centimeters. So okay, let's do it one by one. Show that the area in yellow is 196 centimeters square to the nearest whole number, 196. So realistically speaking, how many marks is this question? I suppose It should be at least 4 marks. Yeah, it is 4 marks. So the entirety of this region, let's suppose this one, it is some sort of you can say a square. So that is 20 square, and that equals to 400 centimeter squared. All right, that is 400. We have to find the area in the yellow region. Hmm, how do we do it? We simply have to remove the two semicircles and the area of the mouth. So the area of the mouth is, look, the area of the entire mouth is 100 centimeters, but the part of our square that we have half of it. So that becomes, we subtract 50 from it for now, initially. Then we have two semicircles that look like this. What is the formula for area of a circle? Area of a circle is pi r square. Area of a semicircle is pi r square divided by 2. It's just going to be the half of it, right? So the radius is 7, so we get pi multiplied by 7 square over 2. So pi multiplied by 7 square divided by 2. So this gives me an answer of 76.96. Wait a second. Yeah, 76.96. So that's the area of just one semicircle, and the entire semicircle, this part is also included. It's going to be just multiplied by 2. So that becomes 153.94. So if we were to subtract all of these values, 400 minus 50 minus 153.94, let's try to find the value. I get an answer of 196.06. Makes sense? I hope. Sixth part B says, the wooden template for mask B is shown below. The area of the mask is 1184 centimeters square. Show that the area of the nose is 18.5. So in front of us, we can essentially see two trapeziums. So if we were to find the ratio between both of them, yeah, let's find the ratio between 4.7 and 37.6. This essentially becomes a ratio of 1 over 8. All right. Now in front of us, this is a ratios question primarily. In front of us, we have length and we have areas. So the scale factor that is used is essentially of k squared. So if we were to take the scale factor of 1 over 8, we'll get 1 over 8 square. That gives us the value of 1 over 64. And if we were to multiply this value by if 1184 by 1 over 64, we would get a value of exactly 18.5 centimeters squared. This was done in a lot of detail when we were solving questions of, um, when we were discussing the topic of, what was it? Ratios and proportions. Yeah. because it's basically a ratios question, as simple as that. Let's move forward now. Oops. Okay. Mask B is decorated with the following instructions. Let's try to read this question in a little bit more detail. Decorated with the following instructions. The yellow paint available can cover a total area, okay, of 80 centimeters square. Use yellow paint to add triangles of two sizes. All right. So it's basically an area constraint equation. So we are being told, okay, we have x equals to 4y, and x is the number of small triangles. So y is the number of big triangles. So when we multiply the number of big triangles with 4, we get the total number of small triangles. And a small triangle has an area of 2 centimeters square. All right. So how to solve this question? Given that there is only 80 centimeters square of yellow paint available, find the maximum number of small and big triangles. Okay, look, I can say the equation is going to be 2x plus 5y is greater than or equal to, sorry, is lesser than or equal to 80. But at the same time, I know that there are x number of x equals to 4y essentially. So I can substitute the value of 4y into the equation. So 2 times 4y plus 5y is essentially equal to 80. So this becomes 13y is lesser than or equal to 80, and y is going to be essentially lesser than or equal to 80 over 13. Now, the maximum number of small and big triangles is going to be, if we divide 80 over 13, we would get an answer of 6.2 somewhere around. But there cannot be 6.2 triangles, right? There cannot be. So our answer is going to be, the total answer is going to be 6 number of, the number is basically 6 is going to be the number of a combined maximum number of big and small triangles. 6 big and small triangles.